Here we have a system of two equations, and normally when you see equations with square roots, you would start squaring them to get rid of those square roots. So you would square each of these equations once, then rearrange the terms, then square it another time. In this case, you will get rid of all square roots, but you will get terms like x squared, y squared, x times y, and other terms, okay? Which we will need to figure out how to solve after that. But it turned out that this problem is much more simple. We don't need to do anything like that. First of all, notice that we are looking for a solution among real numbers. And to get solution among real numbers, we need to make sure that whatever we have inside of square roots is non-negative. Which means that since we have 4 square roots, we need to satisfy 4 inequalities. Now we can rearrange those inequalities and get inequalities like this. But now it turned out there is actually not 4 inequalities we need to deal with, but only 2. Look, for example, at the first inequality and the third inequality, and notice that when x satisfies the first inequality, it automatically satisfies the third inequality. So we can just simply say x greater or equal than 1. Similar thing happens with y, with the second and the fourth inequality. Again, if we satisfy the fourth inequality, we automatically satisfy the second one. So, all right, but now let's go back to our equations. In particular, let's go to the first equation. What do we see here? We see the square root of x minus 1. Well, if x greater or equal than 1, it means the square root of x minus 1 should be positive or 0. Now, what about the second square root? If y greater or equal than 6, square root of y minus 2 has to be greater or equal than 2. But now notice, we have a sum of two numbers. One has to be greater or equal than 0, the other has to be greater or equal than 2. And together, their sum should be equal to 2. That's only possible when the first square root is exactly 0 and the second square root is exactly 2. The first square root equals to 0 when x equals to 1, and the second square root is equal to 2 when y equals to 6. Okay? That's really the only solution we have for the first equation. Now, does it mean that we found a solution of our system? Well, not yet, not so fast. Before we can claim that, we need to check that x equals to 1 and y equals to 6 satisfy the second equation. Because if they don't, it means that our system does not have a single solution. But luckily for us, if we plug x equals to 1 and y equals to 6 into this equation, we are going to get 3. And x equals to 1, y equals to 6 is the solution, and that's actually the only solution of this system of equations.